Hey guys, I got a question on the third problem on the homework, so I figured I would just make a little video here showing it. So first of all, I'm going to sort of draw the hill here. So we've got this hill represented as a triangle right here. This side right here is 8.21 meters. I'll call that H for the height of the hill. This side here, it's not labeled on the picture, but they say that the person goes 32 meters down to the bottom of the hill. So they call it D in the picture, but they don't put the number on there. So that distance is 32 meters. And then up here on top, we've got the sledder here. And so the very first thing that they ask is how much potential energy do they have up here? And the mass of this sledder is 60 kilograms. So in order to figure out the gravitational potential energy of the sledder, we'll use our equation over here. So gravitational potential energy is mass times gravity times height. So plugging in, the mass is 60 kilograms. Acceleration due to gravity is 10 meters per second squared, and the height is 8.21 meters. This height here, that's what determines the gravitational potential energy. And if you do that, you'll get a value of 4,926 joules. Then they say, as the person goes down the hill, that they encounter a frictional force. And that force of friction, they say, is 12 newtons. Now, they encounter that as they go down here. And so one of the questions is, how much work does friction do? Well, remember, work is force times distance times the cosine of the angle between those two. So the distance that the sledder moves is this way, but the force of friction is back that way. So there's 180 degrees between the two. That goes back all the way to when we were actually in school. So it's been 2 weeks since probably we've seen something like that. So anyway, let's plug it in here. So the work is, the force is 12 newtons. The distance is 32 meters, not 8.21. It's the 32 because that's the distance that they move down the hill there. And then the angle is going to be 180 degrees, which gives you a -1. So the work then winds up being 12 times 32 gives you 384, and it's a negative. That comes out of here, but then if you think about it logically, it's got to be negative because friction is going to take away energy, and that's what a negative work means there. So then the last thing is, how much energy do they have at the bottom? I'm going to do that right in this area. So we had up here 4,926 joules. When we got to the bottom, if there was no friction, our kinetic energy would be 4,926 joules. All of this gravitational potential would have converted into kinetic. But friction has taken out some of that and converted it to thermal. How much did it take out? 384. So to get the kinetic energy at the bottom, that's going to be equal to the gravitational potential energy we had at the top, plus any work we've done. But in this case, the work is negative. So you could say minus the work or plus this negative work, however you choose to think about it. So anyway, then you get the kinetic energy is equal to 4,926 joules minus the 384 joules of negative work done. And that is where you get that at the bottom, the amount of energy you have is 4,542 joules.